All right. Hey, everybody. Thanks for coming to the first decal lecture for Kaggle Science. What is it? Data Science for Kaggle.
Still a changing title.
Yeah, it can move at any time. We can become the machine learning decal. Who knows? But basically, we're going to start out with some introductions of ourselves. So we are a team of 5 to 6 people. One person is still negotiable, and so and one person is currently missing, Daniel down here. But I'm Philip Kuznetsov. This is Raul Curie.
I'm Hamza.
James.
And yeah, another person who may join us soon is Jin Park. I'm not sure exactly what his role will be this semester, but
Hi, Dan.
here's Dan.
Hey, what up?
Cool. So yeah, what is this class? Basically, this class is based around the Kaggle platform, which I imagine some of you know. It's basically, Kaggle is a data science platform where you can basically go on and do some competitions, make some cool submissions, try to do some crazy data sciencey stuff, and win money. So here's 2 examples of Kaggle competitions with huge prizes. So in this first one, we see that there's a $100,000 prize for detecting diabetic retinopathy. Retinopathy. All right. So basically, you just take a bunch of images of this of the retina of an eye and try to classify whether or not they have this disease.
Phil, are you recording sound?
I am recording sound.
Oh, okay.
It's on the recording now. Okay. And then the second one is a challenge from 2 Sigma, which is a financial firm dealing with fintech and everything like that. And this one's a huge prize where you can just use data science to figure out what the best solution is. Cool.
Yeah, you guys are going to learn to love and hate Kaggle a lot this semester. So yeah.
Yeah. All right. And so with that, you can see that data science not only has a good payout from Kaggle, but data science is actually really applicable out there in the real world. For example, Netflix used data science to figure out that they could make a new show based on the British House of Cards using Kevin Spacey, because this British House of Cards had really good ratings for the people who watched it, and Kevin Spacey had really good ratings, and then they could realize they could just combine the 2 and make a really great, crazy show.
Yeah, essentially what happened there is they saw that the show was very popular with British viewers, and they wondered why no one in the U.S. audience was watching it. They used some fancy, snazzy data science tools, and out pops Kevin Spacey as
Frank Underwood.
Fuck, I forgot his name. Frank Underwood in House of Cards. So data science is basically being used as the internal cogs to a lot of decisions that are being made in industry today. You don't really see these decisions. You don't really learn about these decisions or how they're made. You just get the end result. And hopefully, we hope to elucidate through this course the theory and kind of the practical
the practical aspects of how it's done and how it affects you guys.
Yeah, and we'll be going into a lot of state-of-the-art stuff. We'll also be going into some more pleasure, just stuff we think is fun in data science, because this is a decal. You're not here to, well, you are here to sweat and slave over a laptop a little bit, but we don't want it to be as brutal as your already brutal courses. So yeah.
All right.
So make sure to have fun.
So here's an example of data science being used to really surpass humanity and human ability.
A short round of Jeopardy. It's going to be hosted by a member of our Jeopardy crew.
So this is
Please welcome
IBM's Watson. I'm sure most of you have heard of it before. It's basically the well-trained bot that IBM is pulling out. And so this is an example of kind of an offshoot of data science, or kind of a field that's a little bit separate from data science.
Why don't you just introduce it?
Yeah. Sorry, I'll do that. So yeah, so this is kind of this is more part of AI and machine learning type stuff, but we will be covering these kind of topics in this class as well, because we think they're also pretty interesting. And so this specific example just has a huge database of just knowledge, and it can basically formulate this knowledge into a Jeopardy response, and outperforms Ken, the best Jeopardy player ever, as well as this other guy who is also pretty good. I'm not sure.
A man, a plane, a canal, Erie, Chicks Dig Me, children's book titles, My Michelle, MC5, and finally, vocabulary.
So I'm gonna skip.
Ken, you're in the first position. Please make a selection.
I've never said this on TV. Chicks dig me for 200.
Kathleen Kenyon's excavation of this city, mentioned in Joshua, showed the walls had been repaired 17 times. Watson.
What is Jericho?
Correct.
400, same category.
This mystery author and her archaeologist hubby dug in hopes of finding the lost Syrian city of Urkesh. Watson.
Who is Agatha Christie?
Correct.
Same category, 600.
All right, so you see it just absolutely dominates. And if we skip to the end, we can see like how much better Watson did than like Ken and Brad. So clearly already outperforms humans in very specific tasks. But or I mean, I guess not but like this shows that we can do this in many other places as well. And even in a lot of times, the best performing like algorithm can actually just match human, and that's good enough for us because well, not only outperforming, but matching is even good enough. Like, yeah, if we can do that, then we can just deploy a lot of human necessary tasks that really require humans onto the servers and just run that. So.
Also, keep in mind, at the time that this video was taken, Watson has really evolved since then and is using more machine learning, deep learning-based techniques now. But for the time when this video was created, it was still using a lot more traditional data science and kind of tools, which you will learn throughout the course of this course. And you'll also learn about the new tools that they're not really telling you about / haven't really like made public yet.
Yeah. So data science in its current form really relies on a lot of machine learning. And this is a part that we're all very interested in. We're all part of machine learning at Berkeley. And I know a few of you guys are as well. So yeah, we really want to make this like a huge emphasis of this course as well to teach like the machine learning behind a lot of data science techniques. And yeah, so I just want to go through some examples of machine learning doing really cool shit. So the first thing that I want to talk about, I guess not talk about extensively, but just an example is that there's this QA system which can take an image of this woman wearing bananas on her face and you can ask very weird questions that you would otherwise not really know the answer to. And so the first question we can ask as like humans inputting into the system is just like, what is the mustache made of? And the system figures out that it's made of bananas. Okay. Now, other things we can do is generate really cool looking artwork. So this is an example from a deep learning.
This isn't really data science, but it's just cool as shit.
Yeah. So yeah, this is a deep learning algorithm called Deep Dream.
Or is it?
Yeah, this is Deep Dream.
Basically, it takes a deep learning model that is trained on like classifying images, and then just takes the output of some part of that model and can make these really cool looking, like almost psychedelic looking images.
And then it takes the output of that model and feeds it into itself again and again and again and again, and it gets really tripped out on itself.
It starts imagining these weird like pagodas hallucinated everywhere, and it's really cool. So something kind of in the same flavor is called artistic style transfer. I'm sure some of you have heard of that before. If you've used apps like Prisma, and there's one other that I can't remember the name of, but basically it takes the high-level representation of an artist's style and is able to transfer it over to an image that has like what is called content, I guess. Basically the specific edges and stuff like that, and then combines them. So you can see this photo from, I think it's Picasso right here, Gandalf, and then combined together you get this this crazy-looking image that very much matches the style that Picasso was drawing in when he was making this original image. And then here's a picture of the Golden Gate Bridge. I'm not sure what the exact source transformation is. It may have been Van Gogh's.
Yeah, Starry Night.
Starry Night. It's Starry Night. Okay, yeah, so Van Gogh's Starry Night, if you're familiar with that. And then we can also even apply this for videos as well. I'm just going to skip to the middle. Here. So as you can see here, we just apply this transformation from this image on the right, and we can apply it to this live video here. Cool.
Yeah, y'all might be wondering why we're showing you stuff with images and art, even though this is data science based, but it'll become very clear later on how the techniques that we use, the techniques that we use to do that, like how they play into data science and getting like as high results as you can in Kaggle.
Yeah, and also they're really cool, so there's no problem with that. Yeah, so this is an example of another type of deep network called a, I think these are all generative adversarial networks. What they basically do, they take in a text input description So up here on the very left, right, your left, this bird is red and brown in color with a stubby beak. And what you can see here are 3 different algorithms trying to generate the same image. And at the very bottom, you get photorealistic images. These are not from the data set. These are not taken ever. They're just learned kind of representations that are then transferred out and made into images. Here's one example. I think I'm just going to skip it for now, but you can go watch it. We'll link the slides. It's basically just an AI playing a game using neural networks. It's pretty cool. It's kind of interesting to know that a computer game is able to do this really complicated maneuver and everything like that. So,
yeah,
go
all
over the
right.
course
So
structure?
enough of the flashy stuff. Now let's get down into some of the content of the class. So basically, the way that this class is going to be structured is we're going to have weekly homeworks. Just to like get you up to speed on the concepts and like give you some practice. But again, this is a decal, not as hard as one of your regular courses. So we want to keep these fairly short to the point. And the next 2 lectures are going to be an optional coding review. So if you already know like Python and in particular like NumPy very well, then you don't really need to attend these. But if you want more practice or like have some questions about this sort of stuff, then like do please feel free to come and ask us.
So y'all get a free pass for this week.
All right, and so we're going, and again, like this is data science for Kaggle, so we're going to be having some projects on throughout the semester to like help you guys like actually like compete in Kaggle and hopefully do well with the techniques that we teach you. And so we have a website that you can see over here. You can go back like through the slides, so don't worry about like writing this down. And for those of you who have a computer open right now, you can even go there, check it out. This will contain like this is a GitHub repo containing like all the slides, all the assignments and whatnot. So like this is a very important resource for this decal. And we also have a website. It's up there, kaggledecal.github.io. I wrote it on the board too.
Oh,
So, well, yeah.
Oh, it's destroyed. I got it. Keep talking.
So, yeah, also like check that out. And again, that's on the slide, so don't worry about writing that down. And again, as we said before, this is James. So if you have any enrollment/logistical questions, this is your guy. He's a really solid guy. Send your emails to him. Thank you, James. I love you.
Right.
All right, and now let's get into grading. So there's going to be attendance for this. We want to make sure that you guys are like keeping up with the stuff and like whatnot. So so the first assignment will be graded on completeness, and then for the Kaggle assignments, the way it is you're going to be like classifying data, so there'll be like a threshold of how well you do. So we're going to grade you based on that. We'll announce what our threshold is, and you guys have to like try to beat that. And then for projects,
They'll be easy thresholds. We're not like trying to put you through gauntlet.
yeah. So for projects, we have like 4 metrics. Completeness and quality, accuracy. So that goes back to the Kaggle threshold, and teamwork. Because in data science, you really have to like work with a lot of people. So we want to make sure that you guys are like doing that well. So yeah, and then we have like 60% homework, 40% projects. That'll be, and then you have to like meet all the accuracy requirements. And then if you want like if you do some stuff that's really like above and beyond, then like come talk to us and we can see if like any extra credit might be on the table. And then late work.
I guess it'll depend on the situation.
Yeah.
So if there's an emergency, talk to us. But like realistically, just turn your stuff in.
Yeah,
on time.
try to turn in your stuff on time. But like if you can't, just talk with us.
Yeah. So as note, we are also students, so we have a lot of other responsibilities as well. And dealing with late work is going to be really difficult, so don't do that unless you have any problems. All right, just going down the list of attendance and stuff like that. Yeah, it's mandatory. Email us if you have any problems.
Also, we should say how we're taking it.
Oh, yeah. So we have quizzes at the end of every lecture, where we'll basically just ask one concept from the lecture. Do you want to discuss more details about that, or is that pretty much it?
Yeah. So, I mean, you should show up to these, but like they are webcasted, so like as long as you do the quiz, it'll be fine. Please come. we're cool people. I know we don't look like it, but we're fun to talk to.
Yeah.
Yeah.
And the idea is that you should be doing your homework with a group of people anyways, so it's going to be easier to meet with them when you're all here anyways. We'll leave some time at the end of class to just like talk and do your homework and everything like that.
Yeah, lectures are actually going to be about like 45 minutes every week. And
Yep.
45 minutes of lab and homework time at the end.
And where you can ask questions and stuff
So
like
it's
that.
not that.
So it'll be kind of like impromptu office hours every day, so or every class. So yeah. Yeah, that's pretty much it. Oh, okay. So you have 3 excused absences or 3 quiz drops. All right. Cool. So we all have office hours. You can find them on the slide. I think. Hey, Daniel, did you post them on the website?
Yeah, it's on.
Okay, so they're also on the website, which is good. So you can find that all there. Just read this. Email us if you have. Or I guess Raul, Dan, and James all have by appointment office hours. Again, just email them if you want to reach out to them. I will always hold my office hours every week unless I post on Piazza or that something has changed.
Yeah, same for me. So yeah, just come find me there at that time.
Oh, I guess we didn't put this on the slides.
I also
Um,
do technically have CS 189 office hours. So I'm willing to take questions then, but like please don't flood my section. Oh, it's 12 to 2 Wednesday.
We can put that on there.
Something like that.
Additionally, we have our Piazza. Come over here. Don't look at this part, but so whatever. Yeah. So come and post questions on this Piazza. We'll try to get to it as soon as possible. Anybody have any questions about logistics for the class? Hey. You're gonna submit your classified data to Kaggle. So yeah, it'll be just like submitting to Kaggle. Some homeworks will not require you to submit to Kaggle. Some will. So.
Oh yeah, and for those of you that don't really know how Kaggle works, it literally just reads in a CSV file of like your classified data results. So it's not like you have to send it some complex like compiled Python model or something like that. You just send it a CSV, it chugs along, does its thing real quick. So it should be pretty intuitive and easy to figure out. Yeah, we don't anticipate submitting homeworks and projects being too difficult of an issue.
Has anybody not used Git in this room? Please raise your hand because we want to help you. Okay, so you and you. Okay, cool. Yeah, we'll come and help you after this just to get you set up. It shouldn't be too bad. You've never used Git?
What? No,
Oh, okay.
I've used it. But I'm trying to set up to the Piazza and I see data science with Kaggle and data science for Kaggle.
For Kaggle is
For Kaggle.
ours, but
Is it really?
wait, there's a clip one.
Wait, this could have been the old one. Hold up.
Yeah.
Go to the CS 198.
Okay, it's 198-072.
Um,
It's not stat if that's.
No, I think the data science.
Yeah, there's the one from last semester. That's stat 198. This one's CS 198.
Yeah, so ours is data science for Kaggle. Yeah, and also if you have a question that you think should be posted on Piazza, please do so, because then again you get the benefit of getting student answers, and other people may have the same question too. So it's good for that sort of thing. So.
All right. So James is gonna go over tools that we will be using in the course.
Okay, so just like a brief overview of the main tools we'll be using. So Jupyter is a Python environment. It's a Jupyter notebook. So basically you run a command in terminal and then you can open up this notebook in a browser and edit Python code and run it within the browser too. It's really handy. Docker is essentially a containerization engine. What that means is basically it sets up your environment for you, so you don't have to worry about dependencies or installing anything other than Docker itself. So that's really nice for like classes like this. And then scikit-learn is probably the main machine learning data science library you'll be using. It's a Python library. It basically has all the typical like machine learning models and these sort of things already implemented, so you don't have to implement them yourself. And then Keras and TensorFlow will be the stuff you'll be using once we get to the neural net section of the course. These are frameworks for neural networks. They make it much simpler to work with neural networks. And now, I guess this is like an image of what Jupyter Notebook looks like. So basically you put your code in here, Shift Enter and it runs this code block, and then you get to see your output here, and then you can put more code on the next line. It's really nice. And so now we're gonna install Docker. So if you go to this link, there's links to instructions depending on your operating system.
So you can just go to github.com/kaggledecal/sp17. I'll write that up.
Also, yeah. So here, if you're on Mac or Linux, definitely use Docker. If you're on Windows, Docker is sadly more of a struggle, but Docker is really awesome. So try your best to get Docker installed. If you have problems, we can definitely help you out. So should I give them time to install it, or just run through the Docker command?
No, let's spend some time installing stuff.
Okay. Yeah, so just spend some time now trying to install Docker, and if you have any issues, just raise your hand.
Okay,
Yeah,
perfect.
So Docker is kind of shitty installed normally, so that's why we want to last time install it.
Once you submit the quiz, we'll send it out.
Yeah.
Yep.
So yeah, if you click the instruction links, it should take
No.
you to our Docker image.
No. We'll go through that once we can leave a little bit more time for Docker install stuff.